Hi, this is the first video, I very discreetly just did that, this is the first video on Unit 7, which is primarily about graphing functions and equations. This is something that ties algebra and geometry together very elegantly, and it is quite difficult if you're not organized. So the first thing I'm going to talk about in this whole unit is how to make a table. And I'm going to stress this over and over again in class. The tables are the key part of this whole unit. If you are having trouble with the tables, either rewatch the video or come talk to me before school sometime or during class, and I'll stick around during lunch if I need to. But you really need to have an understanding of how the tables work. So the first thing is tables. It's a nice way of a nice organized way of finding ordered pairs. That's the key. The end result is we want ordered pairs, but if we misuse the tables or we don't pay attention to them, it can be quite difficult. Also, the second thing unsaid, rulers. You really got to use a ruler while you're making these things because they're going to look sloppy and disgusting. So you want nice. Sorry about that. Totally got interrupted. So again, color pencils, really big key. Please have some color pencils on standby because you're going to be using them for your tables. Also, please bring some to school or some type of coloring markers or something to, no, don't use markers, they're too big. Use colored pencils or crayons or something because it'll make your tables look better. Alright, here we go. First thing about tables is let's just play with the idea of what exactly is a table, the table. What is this? Don't install. Okay, so the tables. Basically, if I make a table, eventually you're gonna choose your own X's and Y's. Or your own X's, then I'll find Y's. So we're skipping a lot of things at first. So the idea is that if I know what X is and I know what Y is, an ordered pair is what they are together. So for the first one, it is 5 and 17. That's the first ordered pair. Next one is -3 and 47. Again, when I read an ordered pair, the first number is X, the second number is Y. Well, the first number is -18 right there, so that must be X. So I'm just filling in the blanks. Look at this one. The first number is 1.9, that's X. The second number is -6, that is Y. So again, we're going to have some X's, we're going to find Y, and then I want you to make an ordered pair. Because that's the main thing, because the ordered pair, those are what we're going to be graphing on the coordinate plane. Well, if we can't find ordered pairs, or we can't find Y, then, well, if we can't find Y, we can't find ordered pairs. If we can't put the ordered pairs together correctly, then we can't graph them. And that's what the main issue is that if we mess up at one step during this dance, the dance doesn't look very good. Two more definitions, domain and range. And I'll give you for instance in a minute. The domain is every number I can plug into a function. Every single number that's going into this thing that I can put in, I can make X equal 5, I can make X equal 6. Those are the inputs. The range is what do I get back? Well, Y equals this, Y equals that. So normally, X is the input, Y is the output. And for us this year, that's what we're going to focus on. For instance, and I'm going to be color coding stuff, so this is, again, where I would like to be seeing this in your notes. X is the domain. X is what I'm plugging in. So if I plug in +4, that's part of my domain. I'm going to get back +2 because the square root of 4 is 2. If I plug in 9, that's an input, that's in the domain, I get 3 back. But I said I can only use non-negatives. I can't plug in a negative into a square root. A square root can only use a positive number. And just like I can only use a negative number, or use a non-negative, and by the way, you can use 0, 0's fine. I can only get a non-negative back. So anytime I plug a number in, I'm not going to get a negative back. So that's why it's the range. So that's the idea, like the domain is what I can put into it, the range is what can I get out of it. Let's do our first of 3 examples. Here we go. Example number 2, and this is basically all of them. I want you to make a table for Y equals X minus 4 for the given inputs, -3, 0, 7. Normally you will be choosing your own inputs. When we get to graphing eventually, you're going to be doing your own. You have to choose your own 4 or 5 numbers. I'm giving those to you for this video. Normally, you will have to pick your own. Here we go. I always start by doing this. I'm going to put parentheses minus 4. By the way, this is just like the evaluate problems that we do with order of operations. I'm plugging in -3, right? -3 minus 4 is equal to -7. And I'm not going to put, and when I end up with my final number right there, I'm actually going to use my blue pencil because that is the range. That's in the range. That's my result. Oh, then that means y must equal -7. Yep. So my ordered pair, and this is what I want, this is the main goal, my ordered pair is whatever my input was, that was x, -3, and whatever my range was, that is -7. That's it. That's the table. So don't get freaked out about, oh man, Mr. V said this is super important. It is. It really is important. But it's not that hard. It's a lot of different things happening at one time, so we're good. And since I've finished that, I'm going to put a little line through to say this part is done. And be like, okay, cool. Now let's plug 0 in. Again, I always start with parentheses, -4. So wherever there's an x, I'm going to put a set of parentheses. I'm plugging in 0. 0 minus 4 is -4. So this is equal to -4. Cool. So my range, or my output, is -4. So -4 is in the range. I had to really scratch my nose. So I plugged in 0, and I got -4 back. Cool. That's my ordered pair. And these would be what I would be graphing. This is what I would be putting on a chart or on a coordinate plane and graphing. Okay, next one, plugging in 7. Here we go. Parentheses, because I'm plugging in 7. So I'm plugging in 7. I know from back in the day when I used to watch Sesame Street that 7 minus 4 is 3. Cool. My output is 3. Bam. I plugged in 7. I got 3 back. Perfect. So that's it. These are my answers. That's all we're doing. That's letter A. Part B. Here we go. Now my equations are they're not always that simple. Like, oh, -4, cool. No, there's usually some more going on. Y equals -3x plus 1. I am plugging in for inputs -2, 0, and 5. So this is why like the table's nice, because it's an organized way of doing this. So here we go. -3 times whatever x is going to be plus 1. I am going to start every single one of those like that. Every single one. Well, I'm plugging in -2. Here we go. -2 times -3 is +6 plus 1, which is equal to 7. That's my final answer. Man, my nose really itches for some reason. I apologize. Mr. V picked his nose the whole time. Yeah, whatever. So my ordered pair for -2 would be -2, which is x, and 7, which is y. That's my ordered pair. Again, it's just, yeah, it is a lot of work, but look how neat and organized I'm making this. And it takes practice. It does take practice. -3 times some number plus 1. Cool. I'm going to plug in 0. -3 times 0 is 0 plus 1. And I'm pretty sure 0 plus 1 is 1. So I got 1 back. Oh, switched over for some reason. And my ordered pair is 0, 1. Awesome. Okay, moving on, moving on, moving on. Okay, -3, parentheses, plus 1. I'm plugging in 5 for x. So -3 times 5 is -15 plus 1. -15 plus 1 is -14. Which means my ordered pair is 5, comma, -14, parenthesis, and you might be saying, ah, you used the wrong color. I did. I was supposed to use green. I apologize. So that's all that's going on. It's just order of operations, and I'm making my order of operations very clean with equals. My inputs, my outputs, putting my inputs and outputs right next to each other. That's the whole point of ordered pairs. We'll do one more. C. Wow, now we gotta deal with quadratics? Absolutely. I gotta square this. This is called a quadratic function. Absolutely. I'm not gonna use the colored pencils this time. I always start with whatever x is parentheses, and this is where it matters. This is major. Order of operations says, do I multiply first or do I take the exponent first? Parentheses, exponent, 4 times 9. -3 squared is +9, which is equal to 36. 36. So my parentheses, my point is -3, 36. Bam. Okay, that's all we're doing. So yeah, order of operations are huge. I could put an absolute value in here, and we'd be able to do it, which sounds like a great idea for a warm-up. 4 times 0, which is equal to 0. We get 0 back, which means the point is 0, 0. 007. So I'm not in a rush. I'm 4 times 1 squared. Whatever I'm plugging in is going in parentheses. That's pretty big. Exponent first, 4 times 1. Now it's 4. So I got 4 as my output. So I plugged in 1. I got 4 back. That looks good, sure. So yeah, plugging in 3. 4 times 3 squared. 4 times 3 is 9. 4 times 9 is 36. This seems really familiar. Interesting. I got the same number back again. 36, 36. Two different numbers might give you the same number. Two different inputs might give you the same output. That's cool. That's quadratics for you. So that's us graphing, or that's us setting up a table. So this is a lot to take in at one time, but it's a very neat, organized way of doing a lot of things at one time. That's what we want to do. Have a good day.